Question 9, identify the indeterminate form and evaluate that limit using L'Hopital's rules. So just real quickly, what I want to do is try and put a 0 in everywhere I can. And in this case, I can do that. And this is going to be, the cosine of 0 is 1 plus 0. And then as I can't really do 1 over 0, but just think about this for a minute. If you put a number that's really close into to 0 in for x in that exponent, you get 1 divided by a small decimal. So just punch into your calculator, 1 divided by 0.000001, and then 1 divided by 0.000001, and 1 divided by numbers that are closer and closer to 0. What happens is you're going to actually approach infinity. So the indeterminate form for this guy is 1 to the infinity power. Now, we can't really do that because infinity is more of an idea actually than an actual number. I can't give you a specific item for infinity because the number that I would come up with, you could just add 1 or 10 and get a bigger number. What we're going to do is we're going to handle this just a little bit differently, and I want to make sure I copy it down right, so I'm going to borrow from my book real quick. But if we look at this limit as x approaches a, okay, which in this case would be x approaching 0, and we take the natural log of our function, okay, the following would be true. Okay, if this is true and there's a limit here, let me back up just one second. Let's just assume that there is a limit here. Okay, then what we can get from that is the limit as x approaches a of f of x is equal to the limit as x approaches a, and this is where it's kind of looks weird, e to the natural log of f of x. I'm starting to run out of room here. And so what that gives us is e to the limit power. And if you think about this, if you look at e to the natural log of x, if you just evaluate just this little guy, it's the same thing as x. Okay, so we're not necessarily doing anything that's illegal. We're following all our rules of algebra. Okay, well, let's apply that then to this problem right here. So we're going to have the limit as x approaches 0 of the natural log of the function cosine x plus x to the 1 over x power. Okay. What we can do with that then is, since we're now working with natural logs, we can move the exponent of this problem, this guy, out into the front of the problem here, and we've got a different setup, and it gets that 1 over x out from being in the exponent. So I'm not going to worry about the limit right now. I'm just going to work with the logarithm part. So it would be 1 over x times the logarithm of cosine x plus x. Okay. Now we can start looking at some different things here. I can change this just a little bit, where I have the natural log of cosine x plus x over x. Now, is it possible for me to use something else? Okay, so are there other steps that I can take, or what can I do to solve this problem out? And it's also possible from here, I could just straight up use L'Hopital's rule, but I need to get an indeterminate form first. So if I look at this guy right here, and I now adjust for my limit, so the limit as x approaches 0, then when I put the 0 in for all of my x's, okay, I get 0 in the denominator, all right? I get the cosine of 0 plus 0. That's the cosine of 1. That's 1. Cosine 0 is 1. The natural log of that is 0. So I get the indeterminate form 0 over 0. What I'm going to do then is I'm going to find the derivative of the top. So the top would be f of x, not f prime of x, not yet. The top would be f of x, and that's going to be the natural log of cosine x plus x. The derivative is 1 over cosine x plus x times the derivative of the denominator, and the derivative of the cosine is negative sine x. The derivative of x is 1. So remember, that's all would be over 1. And so I end up with negative sine x plus 1 over cosine x plus x. Okay? Now dealing with the denominator, that's just the x part. So g of x would be equal to x. G prime of x would be equal to 1. Well, remember, anything over the number 1, in the denominator, we don't write that. So the new limit that we're going to work with then is going to be the limit as x approaches 0 of negative sine x plus 1 over cosine x plus 1. Now we can put 0 in everywhere because the sine of 0 is 0. 0 plus 1 is 1. On the bottom, the cosine of 0 is 1 plus 1 is 2. All right? What this tells us then, since we use the natural log, this tells us that we've got a limit, but now we're going to put that in the exponent of the e. All right? And so our answer then for this particular guy is e to the 1/2 power, or e to the 0.5 power, or the square root of e. All of those things are equal. So this is kind of a cool trick you can use with L'Hopital's rule to get it into a form that we can more readily analytically solve. Okay, we're going to use L'Hopital's rule again. We're going to find the limit as x approaches 0 of sine 6x over 7 6x. So again, always try and plug that 0 in first and see what's going on. If you get a specific constant number answer, life is good. But if you get an indeterminate form, then we've got a little work to do. So when I put 0 in, I get the sine of 6 times 0 over the sine of 7 times 0. And that's going to be the sine of 0 over the sine of 0. I've got an indeterminate form. All right, no problem. What we're going to do is we're going to let the top equal f of x. That's the sine of 6x. And we're going to take the derivative of that. And when you take the derivative of the sine, that's cosine 6x, times the derivative inside the cosine, which happens to be 6. Okay? So what we have for f of x is 6 cosine 6x. Okay? What about g of x? Well, g of x then would be the bottom guy, which is the sine of 7x. Okay? So g prime of x would equal cosine of 7x times the derivative of the 7x, which is 7. So this guy's going to be 7 cosine 7x. All right, this is what it looks like. Well, now come back up and use L'Hopital's rule, and let's evaluate this limit again and see if it makes life a little bit easier. Now I'm going to have the limit as x approaches 0 of 6 cosine 6x divided by 7 cosine 7x. Thank you. And when I put zeros in here, I get the cosine of 0, which is 1, so 1 times 6 is 6. I get the cosine of 0, which is 1, so 1 times 7 is 7. And that right there is the limit for this particular problem on question number 10.